Jacob. Exactly at 3 o'clock. Okay, be here at 3 o'clock.
Okay. Yeah, hello everybody. Today Professor Naik said that I'm always smiling. But I'm smiling just because of all of you here, yeah? I'm very happy to see you all here, and I'm very thankful for Professor Naik for inviting me here. Today I will talk about a little bit of science in my hometown, which is called Novosibirsk. This is in Siberia, in a very cold place. And now I'm working in BITS Pilani KK Birla in Goa campus. So this is outline of my talk, very few points actually. First I will talk about motivation in general. Why do we need to do research in natural science? And then I will talk about my hometown, and at the end I will show you two demonstrations. A little bit about evolution of intelligence. What happened with our civilization? In the last 20, 30,000 years, our civilization was working pretty hard on language development. Somewhere 15,000 years ago, they started to combine together and migrate all over. In the last 2,000 to 3,000 years, our civilization started to develop writing skills, which led to a lot of written text, and then this was leading to development of civilization. About 200 years ago, there was development of natural scientists. And nowadays, we are living in pretty much artificially created world. Everything, mostly what is around us, is artificial. About 40 years ago, we got development of internet and media, and which led to a lot of exchange of the knowledge worldwide. And this is also one of the reasons why our world is developing very rapidly. Nowadays we have ChatGPT, and who knows what will it lead to. But there are natural scientists, the sciences which describe natural phenomena. Okay? All the divisions, so there are some people, the students or somebody can tell, I don't like biology, I don't like chemistry, I don't like physics. But this is all nature, and we have to love our nature. And all these divisions, biology, chemistry, physics, etc., these are human-made. Nature doesn't care about these divisions. Yeah? There are laws, and we have to discover them. The same as equations and laws which we are using, these are human-made, nothing more. Only human created this, and mathematics developed, and the letters we write to write equations. This is all made by human. And all of these laws which we have nowadays, physics, chemistry, biology, this is made by humans as a result of their observation of our nature and doing different research and experiments. And nowadays we are teaching each other for these laws as well. We are giving knowledge to each other. And all of these discovered laws and phenomena which happened, so all of the discovered laws are required for us to predict when we want to do something, we want to predict what will happen with our experiment. And mainly our achievements of our civilizations based on these laws. And this comes to conclusions that natural science is a very important part of our lives, and we need to study it. But there is little problem of our modern civilization. There is somehow 99% of population are not able to understand the most of modern discoveries. They are becoming way too complex. But somewhere 50 years or 10, 30, 20 years after discovery, 90% of population will start using those discoveries. For example, as the telephones. Another problem we have, a lot of information in the internet is not correct. You can find that there are lots of websites, lots of different articles written, but many of them would be not correct as well. And we need to have a knowledge, and we need to understand what is correct, what is not correct. One more problem, a lot of people are watching movies. And these movies are made just for the show. If you look for the explosion in Hollywood movie, and if you compare this to explosion of the car in reality, you will find that this is completely different effects. And this can be a big problem because people are forgetting about safety. You have some kind of cognitive feeling when you need to behave in extreme situation and how you need to behave. And if you are since childhood watching these Hollywood movies, it could be that you can do something wrong in your future as well. And not understanding, of course, yeah, it can be dangerous. For example, if you take iron consumes about 2 kilowatts, 2,000 joules per second. Ironing of pans, you simply home iron pans, yeah, it requires about 2 million joules of energy. And this can be, so the lethal amount for a person, human being to die can be like 2 joules, very little. And ironing of pans can kill about 1 million humans. And one is not thinking about this. We are surrounded by a lot of electricity and everything, and very high energies. And we need to know how to live in such a society as well. Nowadays, mobile phone turned 50. It was just this year, actually. Somewhere in 1973, the first Motorola employee made a call. And now we cannot imagine our life without a telephone. Everybody has a telephone. Yesterday, Professor Naik picked me from Goa. His telephone was ringing every 5 minutes, all the time. We cannot imagine our lives now without those phones. This is super important. I mean, this is just a part of our lives. But who can imagine this 30 years ago? But how many people on our earth can build a phone? In order to design one telephone, it requires maybe hundreds or thousands of people who will be involved in bringing the telephone to a market. And there are different research and development teams. Yeah? They are looking for batteries, displays, cameras, software, and so on, so on, so on. It was calculated that it's required about 25,000 man-hours to design and build one phone, which is about 12 years. Even if you know how to do it. It means if something happens, we will not have telephones anymore. It's very difficult to build one. Something like 20,000 people on our planet know how to do it, which is very, very low percentage of population. But nearly all of us has a phone. The same goes to different fields. Airplane production, cars, computers, medicine, biology, and so on, so on, so on. So natural science is becoming very complex, and it's all over us, yeah, and it's very important to learn it since school time, I would say. As soon as we are able to process the writing, we can proceed with the natural scientist. Okay, this was a little bit motivation. Now I'm coming to my hometown, and I think the city where I'm coming from is really good scientific model and for scientific center. In general, Novosibirsk city was founded in 1893 by builders of Trans-Siberian Railway. I think you can see the bridge here even. And we are there on the picture, there is a bridge. Again, they came to build this Trans-Siberian Railway which goes through the whole Russia, and because of that this city was founded. Nowadays it's the third biggest city in Russia with population more than 1.5 million people in the area of size of 1/7 of Goa. It's pretty big area and quite low populated in comparison to Indian cities. So now Akademgorodok. Akademgorodok is a little town of scientists in the forest. It was founded by academician Mikhail Lavrentiev. Somewhere in the 1950s, he decided that he wants to build scientific center in the middle of nowhere, in Siberia somewhere, in the cold place. And they just got money funding, took a lot of scientists, came to Siberia and started to build it. Nowadays, it's a very successful place. If you look in Google, Institute, Novosibirsk Akademgorodok, This is just Google what is telling me, but there are more institutes. All of these red things is a scientific institute. And we have here Novosibirsk State University, where I'm from, that one, where students living, and all in the walking distance there would be lots of different scientific institutes. And those students who are studying, they have access to this. The same as institutes are collaborating together with institute, with university. So Novosibirsk State University has 3 institutes and 6 departments, which are very much working with each other and working with scientific institutes. And this brings it to rank number 228 in 2021. Now this rank is slowly going down because of the very known things which are happening in Russia. But physics department is rank number 19, and it makes it really a good and competitive university. So there are a little bit of facts of Novosibirsk State University physicists. All of these people who graduated from university, they work in different projects. And here it's about physics, yeah. So they work in Large Hadron Collider. A lot of Russians work at CERN. If you go to conferences for particle physics, you will meet there that 50% of Russian speakers are coming from Novosibirsk. They do a lot of different things. Yeah, they develop new methods how to cure cancer. They build satellites. One of the graduates, Sergei Klimenko, was one of the leaders of the LIGA project who discovered the gravitational waves. And one of them is standing here now and works at BITS Pilani. Why is this so successful? A little bit, just one slide I have about the system. So university very closely collaborates with those research institutes, which gives students from the very first semester to enter them and to explore what they have, which kind of research they do, which laboratories they have. And the students during the first semesters are requested to join those institutes, work together with professors from university. And after each semester, they would need to write kind of publication style report about what they did. Something like 20 pages report about research, what they did in university. From the semester number 1. And this allows students to start working in real serious science from the very early age of their career. And this is really important because you need to learn, you need to understand what is the problems in our life, how to be on top. You need to know how to solve those problems. And you need to first define the problems by yourself as well, what is not known. And of course, this will help them to choose their future specialization, because some people would like different things. For example, during my bachelor degree, I participated in 4 research institutes and worked for projects related for geophysics, electronics, laser physics, plasma physics, and accelerator physics. And then I decided to study accelerator physics at the end. And from 3rd year, students will choose their bachelor degree specialization. Bachelor takes 4 years in Russia, and 2 years master. So Novosibirsk State University Physics Department has about 15 different departments inside. And one can freely choose where you like to go, depending on your experience with those research projects you did before. And one can stay from bachelor to master to PhD degree in the same place without moving. This makes it also very good. When I found that in India you do bachelor at one place and you move to another place and you do PhD in the 3rd place. This is maybe good, but it's not so good. It's better when you focus from the very beginning in one direction and you get familiar with university, with institute, with people, with all the professors. And of course, there is a very huge variety of different physics laboratories. All of those blue-listed laboratories, they will be available for students from the very beginning. They will have to do different experiments there, and they will be involved in these projects. Now, scientific institutes. I said already, if you Google, you find a lot of scientific institutes. There are more than 40 research institutes in the area, and this is all walking distance. I'm coming from Butker Institute of Nuclear Physics, so I will focus now only on that one. This is a very big institute, which has about 3,000 people. It was founded in '58 by Butker, and this was a kind of basis for the laboratory of new methods of particle acceleration. Nowadays, it's led by academician Pavel Agachev, who was supervisor of my bachelor and master diplomas. This is this guy who is together with Putin. In 2018, Putin came and said, we want to build a new accelerator in Russia. And he gave something like 600 million euros and said, build. And Butker Institute is a place which is building accelerators to the whole world already. They have a lot of expertise, but there was no money before. Since the Soviet Union broke, there was no money. And now it's slowly recovering, and they are building the project. This is not the one, this I can skip. So originally they were working for the electron-positron colliders, and there are like 3 accelerators related to this, but I'm not going to go to details. Nowadays, the project which Putin gave money for is called synchrotron. So it's a synchrotron light source, which is called SCIF, Siberian Circular Photon Source. It's a new generation synchrotron light source, which cost about 6 million euros. In India, we have a similar facility, but it's pretty old already, which is RRCAT Indus 2. They're also making an update now, they're doing design and so on. But one of the important features here on the graph is brightness. How much of light you get per the area per the size area. And the accelerator which they built in Russia will be like 4 orders higher than the one in India. So SCIF is located about 15 kilometers away from the Institute of Nuclear Physics in the very quiet area where are no trains, nothing. It's like they took another place in forest and say we're going to build it there. Another reason for this is that there is a virus center. There is a very big collection of different viruses in this area. That's why they want to study them with the accelerator together. It's a very quiet area and pretty nice at the same time. So they just took some part of the field and say we are building 700 to 430 meters area accelerator there. This is how it looks. It looked somewhere on summer. Nowadays, I think they finished the foundations already, and it's winter now. They cannot really do much, but they will finish the buildings in next year, maybe. Brightness is the brightness I skip. Another accelerator there is available in Butker Institute is a so-called energy recovery Linux-based terahertz free electron laser. This is very powerful. I think it's one of the most powerful terahertz sources in the world. Terahertz is a long wavelength. As well, they are working for a new methods of cancer therapy. There is so-called boron neutron capture therapy, and they are now proceeding to lithium neutron capture therapy. So the patient is eating the medicine which contains boron or lithium, and then they are getting bombarded by neutrons, and this is killing the cancer cells. As well, there are available plasma facilities. So there is one so-called gas dynamic trap, and there is a new build, smaller, which was built by my classmate, who is the head of laboratory now there. So the students really, and all of this is available for students from the very early study. From semester 1, you can go and tell, I want to walk the gas dynamic trap. And they will tell, welcome. But research is, of course, expensive. Yeah? It took about 6.5 billion euros, which is calculated to nowadays course. At that time, there is Khrushchev in the middle, who gave this money, actually. And there is Lavrentiev, the guy on the very right with the glasses. This is the guy who built everything, or who founded everything. Now if you look how the different countries are doing with investments, you can find that India is somewhere place 7, which is investing more than Russia actually. So there is money in India, but if you compare for the GDP, it's like 0.7% of the whole GDP is invested in R&D in India. And this number should be increased. If it goes to at least, I don't know, 1.5%, that it will be level of Germany. And this needs to be done at some point. And government should understand that. We need to give research possibilities for the students. This must be, because there are so brilliant brains sitting here as well, but all of them needs to not go to banks, as Professor Naik said. They need to do research. And research possibilities should be given. And not only theoretical. If I look now in BITS Pilani, most of professors are in theory. They study quantum computations, quantum this, whatever, yeah, but most of them are theoreticians. And there are very, very few people who do experimental physics. But you need to do both. You cannot do only theory. You need to do research, you need to do experiment plus theory. And then you are coming to success. Okay, now I'm coming to demonstration of 2 simple experiments. Oh, I still have 18 minutes. I'm very fast today. I asked my colleagues to, not colleagues, I asked some people to help me. I just show you 2 simple experiments, and this was demonstrations which I was looking myself when I was a student in the university, which was shown by Professor Palchikov. And one of them is, we can start with the bottle. Then I can go on immediately. Oh, this so-called vortex machine. I brought here as you very cheaply built. Just it took me, I don't know, 20 minutes to build this. But so there is membrane on one side, and there is just an open hole. Yeah. We filled it now with the smoke. I will tell you what you can use. It's a toy now. Now it's a toy. Very powerful. Up to Professor Naik's goes. If I hit stronger, it will go somewhere far away. Yeah? You see, yeah? This one can be used for. Okay. It's a toy basically. But what can you do with this toy? And Soviet Union people said, yeah, we can use this toy. So this produces such a vortices. Vortex is like rotating circle. And it rotates. And when it rotates, it brings, so when you have the fire, it burns oxygen, okay? And when you have rotating vortex, you can bring the area with the burnt oxygen inside. And this is preventing to stop the fire. There is some little video I showed you from the Soviet Union time. If it's working, and it's not working. Not working. Maybe it needs to load. I have 16 minutes. Yeah, not working. Unfortunately, it's not working. But they would show similar now. But there was some explosion things. Unfortunately. But I have some photos. So what it was used for, imagine you have a gas or oil mine and suddenly it becomes on fire. And this was somewhere in 50 years ago in Uzbekistan. And there was a fire which was 10 to 15 meters diameter and 100 to 200 meters high. And those people in Uzbekistan, they came with army people. With a lot of people came, firefighters. They wanted to stop it with whatever methods available. And this fire was going for more than a month. And they couldn't stop the fire. And then the scientists in Novosibirsk, or in Novosibirsk Akademgorodok got the task, or they got idea how we can stop that fire. And they used this method. what they did is they make kind of a circle around the mine and put explosives there. Okay? And then they put powder, which is stopping the fire as well. And they did explosion. So you can see on second photo. This explosion creates a vortex similar to what is here. The powder goes together with the vortex and stops the fire. Unfortunately, video is not working. There would be visible how to do it. So you just use some amount of 15 kilograms explosion, 1.5 kilogram powder, and it stops such a big fires. And this is incredible. And another experiment we have, if I am able to go back. Yeah. I prepared one more toy, which was one of the favorite experiments of academic Lavretiev, the guy who founded Novosibirsk Akademgorodok, and he was teaching also in our university and showing this experiment to students. As well, I was looking at it, of course. Today I'm going to show you. Maybe many of you would be familiar with that already. So it's just based on the principle of Bernoulli equation. Okay? In the middle of the flow, you will have larger velocity but smaller pressure, and this will create the force which will stuck the ball in the flow. And now this is a toy. You can take any ball. You can take air balloons, very small, like simple air balloons, very light ones. Here would be the roof, it would not work. But you can take different few balls as well, this would work. What you can do with this was another task of Soviet scientists. They were all going crazy about flying to the space. And in the space you have little, how you call, meteorites, which are going with very high velocities. And the scientists got a task to study what happened when such a meteorites will hit your cosmic station or satellite. Yeah? And then there was a task how to accelerate the small metal bolt, which is maybe 1 millimeter diameter, to the cosmic velocities. This was somewhere 60s, 70s in this time. And then they got idea, we can use so-called cumulative explosion. Cumulative is like you have a shape like this, and you put explosion here. And when it explodes, it creates a flow in this direction. This is the same use now in the weapons, in the modern war and so on. Yeah, they use this effect, but for different. Here it was used with a plastic, and then plastic would not destroy the little ball. It would accelerate it to the velocities of 7 to 12 kilometers per second. Okay. Very, very simple toy, which led to a good discovery. And then, of course, they built the whole gun, which was, I don't know, 3 meters long. And this was accelerating little bits. And they studied effects, what happens. And they discovered also that when you have metal which is accelerated to such a velocity, it's behaving like a fluid. Every particle of the metal will be like a fluid already. They will be not connected to each other. It's like a liquid. Okay. Yeah, with this I'm coming to conclusion already. Now we are living in a very rapid and fastly developing world. It's sometimes even difficult to follow all the publications which are coming out. I mean, in order to stay fit in the physics or accelerator physics or whatever chemistry, you need to read all of these publications. And it's tremendous amount. When you go to international conference, there will be hundreds of proceedings papers. If you go to journals, there will be lots of journal papers. And you need to read all of them. So it's very important to learn natural scientists, both theoretical and experimental. It's very important to work by hands as well and do experiment yourself. What I observed in India, people don't like to do experiment by hand. But if I remember my supervisor, who is director of institute now, he would always join us, simply just by the way, comes to us when we were doing research. He would come to the lab and screw the screws himself. And I think this has to be. If you are a physicist, if you are experimental physicist, you must do work by hand as well. And in India, it's philosophy. India it is what it is. So that's why many people, I think, here are going to theoretical directions and so on. And the last point I have here, I was teaching here now for 1 semester only, but I observed that India has a really great capacity of the brain power. When I look on the students in BITS Pilani, they are all super brilliant people. But there is but, yeah? When you ask them, what is the second Newton law, first Newton law? They will all, not all, but 90% of students will tell you definition from the book. They will be like, blah, 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 blah. Yeah. All of them, the same. And I'm asking, do you have your own words? Do you understand what it means, or do you just learn definition? Yeah. For me, physics was always, you need to understand what it is about, and then you can formulate by your own words. And in order to understand, you need to feel those experiences, those laws. You need to go through the experiment, and then you can understand what's happening. Okay. Yeah, with this I want to thank you for your attention. And here's a little sketch from the temperatures in Novosibirsk. If you look for the record high, it's like 37. And if you look for record low, it's like minus 46. So we have about 80 degrees of difference of temperature. And now here we have 35, and I'm super hot sometimes. Okay, thank you for your attention.
Thank you, Dr. Yuri Petnev. Now the floor is open for questions.
Professor, thank you for a nice presentation. You are showing the table, in India in 7th place. Yeah. But GDP, it is, you are showing India in 2018, but you are keeping others in 2020-22. Now our GDP is very good.
Now it will be more?
Yeah, maybe.
Maybe, then I would be very happy. I still think that India is exponentially developing country. This is also the reason why I came here, because I see a lot of capacity, a lot of possibilities for India to grow up. And one problem of India, I also think there is, a lot of people, or a lot of professors, when our students will go abroad, most of students will want to go to Europe, to America, to whatever. And I see it as a little bit of problem for India, because you are investing a lot of resources to grow up these students, very strong, very good students. But then the best would be leaving. And they would leave because there is not much research actually to do. Yeah. And
Definitely.
they would just get more possibilities abroad. But what you observe later, most of the people will come back.
Yeah, definitely.
There are a lot of professors in BITS Pilani we have who were somewhere, most of the people were somewhere outside, and then they all came back.
Yeah, definitely.
And there is a reason, because India is a great country.
Yeah. Thank you.